Often when one is introduced to the concept of RESTful services, the first question that comes up is, what is it? Or what does it mean? Hi, I'm Todd Frederick from Pearson eCollege, and in this quick video, you'll get an answer to that question, what is REST? We'll quickly cover the primary tenets of REST and the 6 constraints that make it unique. This will give you a base of knowledge as we move into the more technical aspects of actually doing REST services. The answer to the what is REST question will inform the why for what we're talking about as we move forward and build out our services. So let's get into a little introduction. So real quick, an overview of what we're going to talk about today. REST is short for representational state transfer. We're going to talk about how it's resource-based versus action-based in some other service systems, and the representations that are passed back and forth between client and server. Then we're going to talk about the 6 constraints of the RESTful architecture, those being uniform interface, statelessness, client-server, cacheability, assumption of a layered system, and code on demand. So as mentioned, REST is resource-based, and all that means is in a RESTful API, we're talking about things or resources instead of actions like you would talk about in a SOAP sense. So in other words, we're talking about nouns versus verbs. In a RESTful API, we're talking about the nouns being resources, like a person resource, a user resource, a address resource, as opposed to verbs that we talk about in something like a SOAP RPC sense, where we would talk about the methods or the actions that we can take on that API. In a SOAP sense, we'd call get user data, whereas in a RESTful sense, we would call something like we would call a URI or a resource, and we would use the HTTP verb to dictate what operation we wanted to do on that. So the resources are identified by the URIs, and those individual resources are identified in each request. It's important to note that multiple URIs can refer to the same resource. And what I mean by that is you can have a URI referring to, say, a person resource, and we can perform multiple operations on that that correspond to the HTTP verbs. In addition, there might be different ways to get at different pieces of resources data, and as we progress through this program, we'll talk about what that really means. But right now, in short, we just want to know that it's possible to have multiple URIs pointing to the same resource. In addition, it's important to note that the representations are separate from the resources themselves. So it's just important to note that the representation is not the resource, it's a representation of the resource. Seems kind of obvious when you talk about it, but there can be different representations also for a given resource. So different shapes of data being returned based on the resource and items in the request. So anyway, the summary of this particular point is that REST is resource-based or noun-based instead of action or verb-based. The term representations is how resources get manipulated in a RESTful API or architecture. They represent part of, or might represent the whole, but in general they represent part of the resource state. And that representation gets transferred between a client and a server when the client holds a representation of a resource, including any metadata or whatever that is attached to that particular request, it has enough information to modify or delete the resource on the server, of course, given that it has permission to do that. Representations are typically JSON or XML. Of course, there can be different shapes of representations. You could have a CSV, comma, separated values list. You could do HTML. Typically, the RESTful services are, have representations that return JSON or XML. So if we were to talk about a quickie example, if we had a person resource, Todd, say me, we might have a service that talks about that person's contact information, and to retrieve that we would use the HTTP verb get, and the representation that we would get back might be name, address, and phone number for this person, Todd, in JSON or XML format. So tiny little pieces of information. Well, tiny might not be the operative word there, but it's a representation of a resource's state that is transferred between client and server. And in general, they are in JSON or XML format, most commonly JSON format. The REST architectural style describes 6 constraints that are applied to that architecture. You'll hear about one of them being the uniform interface. And the uniform interface constraint defines the interface between client and server. And all that means is, it's a complicated sentence full of buzzwords, but all that means is we use the HTTP spec with URIs being our resource names, and we use the HTTP verbs as the actions that we're going to take on those resources. So that's a complicated way of saying it, but it's just really easy. We're using HTTP. RESTful doesn't have to use HTTP, but it just describes an architectural style. But if we use HTTP for the basis of our REST architectures, it makes it simple for us. We know what the interface is, that uniform interface, and it simplifies what we need to do, and people find it easier to understand that way. So this is fundamental to RESTful design. For us, as I mentioned, we're using HTTP verbs, primarily the 4 of get, put, post, and delete. There are others too, options and head, but those are used less frequently. Our URIs are our resource names, and we get status and representations in the HTTP response body. The constraint of statelessness means that the server, the host of the RESTful service, should contain no client state. And that means that each message is self-descriptive. In other words, each request has enough information or enough context for the server to process that message. So, as a sidebar, that kind of implies that if there is state, that state is kept on the client side. So in other words, that representation that we talked about earlier is what carries the state. So between the representation, the HTTP method, get, put, post, delete, and the URI should contain all the state for the given request. In general, that's pretty easy to do once we have a framework or a way of building services that handle it that way. There are things that are built in a REST-like style that that are not stateless. OAuth 2 in particular, three-legged OAuth, is stateful, but it's built in a RESTful fashion. So there are cases where you have to retain state on the server side, but then we have to know that it's not officially or technically RESTful. And in general, we should lean toward statelessness if at all possible. We've been talking about how representations are transferred between client and server. So we've already made the jump to the fact or the constraint, in this case, that a RESTful architecture is a client-server architecture. And that's fine. We just need to always assume or always know or have in the back of our mind that we're dealing with a disconnected system here. So a client of a RESTful API needs to understand that it won't always have a direct connection to a database or direct connects to assets or these resources. That keeps us separate, keeps things separate. If you're writing a user interface, for instance, that's using RESTful services, it keeps the separation of concerns really defined between what's user interface and what's services. So we've also talked about the uniform interface, in our case being the HTTP stack, and that's the link between the two being client and server. So it's just an understanding that RESTful architectures are going to be client-server. Another constraint on RESTful architectures are that they must be cacheable. These server responses or representations are cacheable. Anything that comes back from the server or a REST service could be cacheable implicitly, explicitly, or it could be negotiated. So if it's not denoted, in general, a client can cache something. That would be implicit caching. Explicit caching would be that the server specifies what, max age, duration, those kinds of things. And then a negotiated caching scheme is when client and server negotiate to figure out how long an item can be cached. The layered system constraint kind of goes hand in hand with the previous two we mentioned, cacheability and client server. Basically, we just need to understand that a RESTful architecture could have multiple layers of software in the mix, meaning that as a client, I don't know exactly who I'm talking to. In other words, I don't know if when I request a resource, if I'm getting a cached something or if I'm getting something clear back from the database. So it helps us keep in mind that separation of concerns and that things that I shouldn't be concerned about, so that as a client, all I know about is that API, and I know what footprint or what shape the representation is that comes back. So, probably by now you get it. This just improves scalability from a standpoint that from the server side back, things can be cached. We might be endeavoring to release work from the database or from the REST services themselves. So anyway, it's just important to understand that this could be a layered architecture. So there might be software, hardware, middleware intermediaries between the client and the server, and it's just one of the constraints on a RESTful architecture. And the code on demand constraint is kind of unique. So basically it just means that from a RESTful service standpoint, that server can temporarily extend a client by transferring logic to the client. So in other words, logic or executable something could be transferred as the representation to the client. So, for example, we've all seen Java applets. We won't talk about the pain we've experienced in that. Another example is executable JavaScript snippets. So anyway, code on demand is unique as a RESTful architecture constraint because it's the only optional constraint. The brief summary of these constraints then is that violating any of these constraints other than the optional code on demand constraint means that a RESTful service is not strictly RESTful. I gave you the example previously of three-legged OAuth. So because there is a phase in there that maintains state, it's not strictly RESTful even though it's constructed in a REST-like fashion. So we always want to lean towards supporting these constraints because with compliance we get all these lovely ilities that we're after as we create internet scale applications. Scalability, simplicity, maintainability, all those ilities that we know and love so well. So we should favor compliance as much and as frequently as possible. If you would like some additional resources and insomnia reading, then you might try the REST API Design Rulebook by Mark Massey. That's the newest book in the list here, being published in 2011. The classic RESTful Web Services by O'Reilly was in 2008, but most of it is extremely current and still very relevant. The RESTful Web Services Cookbook is its companion, and it's very helpful for recipes on how to do particular pieces of RESTful services. You know, what HTTP status codes to return in a given scenario, and how to use the 4 HTTP verbs. Now, we'll talk about those too as we progress through this series, but that's a very good supporting handbook there. And REST in Practice, that Hypermedia and Systems Architecture by Jim Weber, is a good book too. It's very current, being written in 2010. That gives a lot, it kind of is a mix of the previous two there, but those 4 are very helpful in understanding the constraints, how to build appropriate RESTful services, and offer a lot of supporting information there. Continuing our discussion of RESTful services, up next is a video about RESTful quick tips. These are quick hit suggestions for making better RESTful services. It's just 6 tips to get you going quickly. We give a little detail and little overviews of the 6 tips and how to create better REST-like, if not completely RESTful services. And if you have any questions, ping me. Again, my name is Todd Frederick. You can email me at toddf@ecollege.com, and I look forward to hearing from you, and I'll see you in the next video.